one, I will introduce the identifying default of quality characterized by using LSTM methods case study. The outline of this study is as follows. The first is introduction. I will briefly introduce the background and the purpose of this study. And the next is related work. In this section, I will briefly introduce the LSTM method and BPNN schemes. And the next is method. In this session, I will briefly introduce the data preprocessing and the parameter settings for the LSTM methods and the BPNN classifiers. And next is the numerical result, and finally some conclusion are given. For finance bank, credit card default prediction and credit approval are significant missions and challenges. In credit risk management, many methods have been used, such as expert systems and statistical methods. For studying these classifications problems, supervised learning algorithm can be considered, such as BPNN, Sgdm, and KNN and random foresters. Deep learning is a subfield of machine learning, and many supervised and unsupervised deep learning network have been developed, such as CNN and PNNs. The RNNs. The RNNs update the weights of network topology by using the EBP algorithm, which causes limitations such as gradient vanishing and exploding. To overcome the drawback, the long short-term memory approaches with advanced RNN cells have been developed. A standard BPN updates the weights of network topology by using the EBP methods, which is GDA. The GDA uses a local optima method, so it is easily checked into local optima. To overcome this drawback, a SCGA algorithm has been developed. To evaluate the performance of the LSTM classifier, this study used the LSTM with 3 training algorithms. They are ADAM, Sgdm, and Rmsprop. This study used the classifier to credit scoring problem. The data set was taken from UCI machine learning repository. This is a imbalanced data set. Machine learning and deep learning. Machine learning algorithm which consists of supervised, unsupervised, and reinforcement learning. The difference between the machine learning and the deep learning are that the deep learning approaches can extract high-level features from a huge amount of raw data by using a general-purpose learning procedure. LSTM methods. We can see that this is the network topology of the LSTM. The LSTM use 4 operators. They are forget get, input get, output get, and memory cell. BPN schemes. BPN is a multi-layer neural network, which consists of an input layer, some hidden layers, and an output layer. The parameter settings for BPN include the number of hidden layers, the number of hidden neurons, and learning rate. To evaluate the performance of the optimizers based on gradient method, this study used the BPNN classifiers with the Sgda and the SCGA. Performance evaluation factors of a classifier. For a binary classification problem, a confused matrix is used. We can see that table 1. The confused matrix is composed of TP, Fn, Fp, and Tn. To evaluate the performance of classification models, this study used 4 factors such as accuracy, precision, recall, and F1 score. This study used the F1 scores is the first factor. The F1 score balanced recall and precision. And the second factor is recall method. This study used the LSTM and BPNN classifier to identify a credit scoring problem. This study selected the best result obtained from the LSTM and compare the result with those obtained from BPN, Sgda, and SCGA. One-way ANOVA is performed. The visual test is then excused when the one-way ANOVA is statistically significant. Data description. A data set description. The data set consists of 23 features and 30,000 instances. We can see table 2. Table 2 shows the description of each features in the data set. This study used 90% of the data set to train the LSTM and the BPNN models and employ the other 10% to test the models. Data preprocessing. A data normalization is used to rescale the future value to create an expected inputs as defined by using equation 5 like this. Table 3 lists the parameter set for the purpose of LSTM classifier. We can see that the LSTM classifier uses 3 training functions. They are ADAM, Sgdm, and Rms. The number of hidden layers. The number of hidden units used in this study for the LSTM is 10, 20, 30, 40, and 50. Table 4 lists the parameter set of the BPNN classifier. We can see that the BPNN classifier using hidden neurons 10, 20, 30, 40, and 50, and learning rate is 0.1. Classification threshold value. For an imbalanced data set, a CT value should be carefully defined. This study employed CT values 0.3 and 0.5. Numerical result. The deep learning and parallel computing toolbox in MATLAB was executed on a notebook. The LSTM and BPNN classifier were performed based on parameter settings. Several numerical results were summarized. What was the mean, training and testing, accuracy, precision, recall, and F1 score, and the mean computation time. Table 5 lists the best numerical result obtained from the LSTM methods with CT value 0.3, we can see that the LSTM-Adam can find the best mean test F1 score. And Table 6 shows the numerical result yielded from the LSTM methods with CT value 0.5. Also, we can see that the LSTM-Adam can attain the best mean testing F1 scores. According to tables 5 and 6, the factor recall and the F1 score obtained from the LSTM classifiers with CT value 0.3 are superior to those obtained from the LSTM classifier with CT value 0.5. Numerical result obtained from BPNN classified, referring to the tables 7 and 8, the factors recall and F1 scores obtained from BPNN classifier with CT value 0.3 are superior to those obtained from BPNN classifiers with CT value 0.5. Comparison. Table 9 lists the comparison results. For frog issue, the factor recall is important. Therefore, a one-way ANOVA was performed and indicating that the p-value is smaller than or equals to a significant level 0.05. That means at least 2 testing recalls are statistically different. Therefore, the future test was then excused, showing that the mean recalls obtained from the LSTM-Adam and the BPNN-SCGA are identical and are superior to that of BPNN-SCGA classifiers. Also, the LSTM-Adam took more computational time. Learning algorithm of LSTM-Adam, BPNN-SCGA, and GDA classifiers are EBP algorithm based on graded methods, based on numerical result. The LSTM-Adam and BPNN-SCGA method can overcome the drawback that trips into local optima. Conclusion. For the imbalanced dataset, a CT value must be carefully selected. For the LSTM method, the performance of the ADAM optimizer is superior to the Sgdm and RMS algorithms, and the LSTM-Adam and BPNN-SCGA classifier can achieve the same or identical performance. Therefore, the LSTM-Adam classifier has the potential to deal with credit scoring problems, which are binary classification problems. Future work will compare the performance of the LSTM-Adam with those of supervised machine learning algorithms such as SVM, KNN, and logical regression classifiers. Moreover, this study will use the resampling method for the imbalanced data set. Thanks for your kind attention.